Hey, Stefan.
Hey, Mark.
How are you tonight?
Not too bad. Yourself?
Not bad at all. It's coming down.
Yeah, it is. The drive was just horrible from the university.
I bet. Do you take the tunnel or the bridge to get?
The tunnel. I live 5 minutes away from the tunnel.
Oh, not bad.
But with the construction, usually after these classes, I usually take the bridge over.
Right.
But today with the cancellation, kind of made it. I figured I might as well take advantage of it. But the roads weren't too friendly.
No, they weren't, I'm sure. So, Casey, I'm sorry I'm bumming you out tonight that we're having class. This is right, the virtue of doing this stuff online. You can have your, you can have your Garfield the cat, pajamas on, right? You can have some home cooked food tonight while we're learning, right? You can have your Bugs Bunny blanket on, right?
It's a soccer blanket, but
Who canceled? Who did you have that taught online and canceled class with the rest of the university? Who did that?
Dustin Atchell.
Oh, really?
Yeah, it was earlier this semester. That one day, it was like a Friday.
Right.
Classes were canceled, and he canceled class too.
Uh-huh. He's going to be lecturing to us later this semester.
Yeah, he told me. I was really hoping it would get canceled. I got other classes to catch up on.
Yeah. Well, I mean, I could watch NCIS tonight if it wasn't for you guys, right?
I mean, you could still watch NCIS.
I don't think so.
Just
I don't think it's on past 10 o'clock.
Just ignore it. Tell everyone to ignore your email and then go watch NCIS.
Yeah, well,
and I'll do my BIM.
Terribly responsible of me.
Everyone's got to let loose sometimes.
That's called summer vacation.
Well, it's almost spring vacation. It's like the same thing.
Yeah, I'm going into work tomorrow. I don't know about you. I don't get summer vacation. I don't get spring vacation.
I got one job off, the other one not.
Right.
I'm not going anywhere.
John, how are you tonight?
Hey, good, thanks. How are you?
All righty, sounds good.
I can't believe this, all this snow and holy.
Yeah,
man.
it was like 60-something degrees yesterday, wasn't it?
Like, what gives, man?
Yeah, well, March is always like this, right? It always lets loose with some sort of monster snowfall. And I mean, I don't know what the weather for the rest of the week looks like or the weekend, but yeah, it jumps back up to 40 degrees. And look, it's sunny tomorrow, so that's all right. It's about 40 degrees for the rest of the next week.
Nice.
Yeah. New York is 54. They always have nicer weather than us. No idea what Vancouver's looking like. I'm sure they're getting something. They got a lot of snow out there.
They're always getting rain or snow or sleet.
Yeah. They got a lot out there. Good evening, Fajer. Good evening, Alec. How are you all doing?
Good. How are you?
I'm super sparkly. I have this feeling, Fajer, that you have like 3 other classes that you're like participating in at the same time as our studio. You're like the most impressive online multitasking student I've ever seen.
I'm talking to Hong right now.
But he's not talking. He's just sitting there.
Wait, where is he?
He's
Yeah,
right
there
there.
he is. Yeah, right there.
He's here.
Yeah.
There's two of them. Did they make you get your haircut?
Our little
Hung?
group.
Did your parents make you get a haircut today?
No,
No, maybe something's a little different.
I just woke up a couple hours ago.
That's like the classic student, 5:30 in the evening, and they just wake up. I know you're in Hanoi. I'm just pulling your chain. Caitlin, how are you?
Good. How are you?
I'm fine. Send another one to Dan. He may be running late. Hey, Trevor. Hey, Cody.
How's it going?
Good. Well, Dan must be running into some weather issues. I don't see him yet. Casey, when is the Freedom by Design event? Is that the Larry Scarpa lecture? Is that weekend?
Yeah, the auction.
Yeah.
Yeah, it's the same day as.
So is that this month?
Yeah, I think so. March, right? Sometime later in March.
It's a Thursday night.
Let me. It is March 22nd.
That's what I thought. I put an item in for the auction for you guys.
What is it?
Well, I can't tell you. You'll see it though. It's the same one I did last year.
I won't be able to afford it, but
Oh, it starts at nothing. You know, it's like $25. You got that rolling around in your glove box, I bet.
hold on. Let's take a gander at my bank account right now.
No, don't do that. You'll get depressed, right?
Yeah, I have. Oh, you can't see it.
No, I'm not looking that hard. I don't want to know.
I got $5.
Why are you showing us that?
We're all gonna get depressed.
No, they're all gonna be happy if you got $6.
Yeah, actually, I am happy right now. I feel better.
Yeah. You can write it. You can write a check and post date it, right?
I got a credit card.
Yeah, be careful with that.
I'll just change my name and move.
So I know Cody's here. I know Nathaniel's here. Nora's here. Richard's here. So is Trevor. But we're missing Dan, and we sort of got to have Dan for this session. And we can wait, but I did complete and distribute to you all Benchmark 2's assignment. It's just a simple 2-page document that talks about the sort of the terms of engagement, none of which for this next sort of month, not quite a month, and none of which should be a surprise to you in terms of the content, right? Structural strategy, HVAC strategy, building enclosure strategy, ADA accessibility, as well as life safety. Those are all criteria, right, that you saw on the first benchmarks grade sheet. And as I mentioned a couple of times on Tuesday night, those individual criteria will have more restrictive or more expectant language. And some of them will have more significant percentages attributed to them. We'll still end up with 100 points for the next benchmark, but we'll be blending those numbers a little bit more evenly along the top, and that will help you sort of get the grade that you're hoping to get. So if you want, we can go over that now while we're waiting for Dan. If there's any questions, I've got it pulled up here, and I can look at that. The critic that we're going to have for the Thursday night session is Jason Lee. Jason's on the faculty, and I have not determined the other sort of guest critic for the Tuesday night session, but I am working on that. I actually may invite Michael back. But I also like the idea of sort of blending it up a little bit and bringing in someone else. I actually have someone in mind for it, so I'll announce that to you as soon as possible. So I've got that program brief open if you have any questions. Perfect. It must be as, clear as mud. 3 pages. All right. So what are we doing for spring break, Hung? You going to travel around the countryside?
Say again?
What are you doing for spring break? Traveling around the countryside?
Yeah, traveling, visiting my grandparents.
Good.
You know,
That sounds good. Any runs for you, Nathaniel?
No, I got 3 projects due in the next week. So
no St. Patrick's Day runs on your horizon?
Nah, it's still too cold. I'm a fair weather runner anyway.
Yeah, we've got one coming up in the Sunday before the 16th, and it's usually a hit or miss kind of day. So it'll be the 11th of this month, and it could be 70 degrees or 7.
Yep.
You just never know with that run. But I know that she's paid for the registration, so I know that we're going downtown. So that'll be a riot.
Yeah, my wife and I have a half Ironman at the end of May that we're training for. So, no, it's not that bad.
I just watched the cross country and the biathlon stuff, last week, and then it made me vomit just watching how hard they were working.
Yeah, they go harder than me.
It's pretty impressive. Okay. Well, I still don't see Dan. Jonna, you may have been the last person to talk to him today. John, you may have been the last person to talk to Dan today. Did you talk to him or just see him in the hall?
Oh, I just saw him in the studio.
Mm-hmm.
That was earlier. I was wondering though, because he was, I was just leaving and he was still at the studio. I'm sure he had another course.
Right.
I thought with traffic, and I thought traffic was going to be pretty brutal.
Right. Right. Yeah, Desmond, classes are canceled tonight. What are you doing here? Are you unable to be in class because of the weather? We're online, right? See, this is why you took the online section, right? So that the weather would never impede you. I'm dead. Jeez. I'm looking at your chat box of misery, and I'm looking at Casey's I'm broke, and you know, Nathaniel is just too freaking busy to do even you know, a green beer run. This is a pretty pathetic group. I
I'll
hope
drink. Don't think I won't.
I hope you guys see.
Don't take that from me.
Right, I'm sure, but I'm hopeful that you guys get a chance to recharge. Yeah, you probably do. If it's any consolation, Desmond, I need the break too, because I sit here the whole night, right? And I speculate that I'm a lot older than you guys. I'm probably a lot older than your parents. It is a good quote. I actually may tweet that. I may tweet that I said that to all of you all, and I'll send a link, you know, to Twitter that, you know, that gives some veracity to the snarky quote that I just gave you. Yeah, Desmond, I think I'm older than your boss, actually. Yeah. Yeah, ask Eland how old he is. He's too lovable. He's too easygoing. Yeah, he was actually, Desmond, he was actually the very best draftsman I'd ever met. He drew just beautifully. I mean, his like the draftsmanship, right? The quality, the craftsmanship of drawing, lettering, sheet composition, line weights, just the way he did everything in his drawing sets were some of the most beautiful documents you've ever seen. Just unbelievably beautiful. And his section drawings were, you know, your jaw would just drop. They were amazing. Yeah, well, because you all kind of do the same buildings over and again, right? So that maybe contributes to it. But back in the 70s, the late 70s, mid to late 70s, actually, we had a number of design projects that we were doing that we hadn't sort of done before. So it required some, you know, assembly, right, to put together. You know, that office actually was the architect of record for Lakeside and Fairlane Mall. Did you know that? No. That was JPR8. Yeah, I know where you all are. Fairlane is in Dearborn. And Lakeside is in Sterling Heights, right? And they were all brought online around the same time, like 1974, 75, 76, something like that. Actually, Jim Ryan of JPR8 used to work for and with Bill Eland, right? Used to work for YE. He was he was there probably in the late 60s, early 70s. He was not there when I joined the company. I think he opened his own office in like 75 or 76, something like that. I joined the company in 76 or 77. I can't remember when, but yeah, the best draftsman I've ever seen, and I emulated him. I I looked at his work and made sure that I could do it better than he could. Yeah, they probably are, Casey. You know, all of those venues get kind of tired, and I don't know. I actually don't know who owns that. You know, I don't know if that's a Taubman mall, but they have to get recycled a lot. If you ever go to like Lakeside, you know, those stores have to go through a major renovation like every 5 years. And so they have to close down and do that renovation. And in some cases, their bottom line is so fragile that they will operate out of one store, perhaps on, you know, like one side of the mall, and then they'll be building another venue, another store in another space or on the other side of the mall. And they let one go dark, and then they turn the lights on in the other space. And they literally they don't miss a beat, and that happens a lot. Yeah, and Partridge Creek is interesting too, because that's obviously one of the so-called lifestyle centers, right? Where there's sort of this semblance of public space, right? Where you know, it's ersatz public space, right? It's fake. You can't like sing political anthems or smoke marijuana on the corner. But you can walk your dog, right? You can shop outside and then go into the stores. So Partridge Creek is kind of an interesting place, but it's modeled, as you probably know, right, on the original Northland, which came down about a month ago. Northland on Greenfield near 8 Mile, and the Lodge just down the street from Lawrence Tech. And Northland became an enclosed mall in the early 1970s, but originally Northland was a series of discrete buildings that you kind of walk to through pergolas and arcades and colonnades, and it was basically all outdoors, right? Just like Partridge Creek is today. Not unlike the JPRA version of, I think it's called Fountain Square, Jasmine, out in Novi, Fountain Walk or something like that. Yeah. So yeah, those are modeled on something that was created by the Viennese architect Victor Gruen, Gruen, and Gruen came to the States. I think he was out of Philadelphia, and he had this this idea about a retail kind of vision that was modeled, as you can imagine, right, on kind of like European streets, where you could walk around and be outside and smoke hand-rolled cigarettes and get an espresso. Of course, we didn't do any of that back in the 1950s and 60s in America, but he created that vision. And for the record, the very first large tenant was J.L. Hudson. So they opened their first satellite store, their first suburban store in Southfield, Michigan. Their original location, of course, was on Woodward at Grand River, and pardon me, and Gratiot at not Gratiot, rather, in Detroit, and it was that sort of big amalgam of masonry. that we tore down in probably 95 or something like that. But the original, that was actually one of the very first malls in the country. Gruen had designed another one, I think, in Minnesota, and it came just a little bit before ours. But for all intents and purposes, Northland was one of the preeminent sort of shopping experiences in the world when it came online, and we had it here first. But it was, like I said, it was one of those outdoor environments where you would be walking around on a night like this to go shopping, but protected, right, by these continuous linking arcades. There would be outdoor areas to sit. There would be planters, water features, sculptures, and it was, you know, on paper, it was a really interesting idea. But like I said, in the 1970s, maybe 10 years later, they started to create roofs over these pavilions and these outdoor areas, and started to drop floor tiles, right, and interior features, and then they began to heat and cool those spaces, and that actually became the beginning of the end of Northland, which I think probably closed, you know, 4 years ago, at the end of it all. It's cool stuff. And Jim Ryan is actually an alum of our program. He was the very first Distinguished Architectural Alumni Award recipient, and that was 21 years ago. So he's still around. He's still a very outspoken architect in the community. Hope you guys have a chance to meet him sometime. Maybe we should get him to come in and do a review. Well, I don't know where your professor is. Let me see if I can text him. Okay. Okay, I just texted him. Any of you guys going to grad school somewhere else next year? Any of our undergraduates? You're all moving through the system at Lawrence Tech? Cool.
Bunch of loyalists. That's good.
Right. Do you guys need to make application, or do you have a portfolio review like at the end of this year or at the end of your junior year to make sure that you're...
If you have a 3.0 or above, you're automatically in.
I see.
So if you don't have that, then yes, you have to provide a portfolio.
Right,
and,
that makes sense. I think I remember Scott saying that now. Yeah, because the grad students need to have a 3.0 anyways in order to graduate. Because in grad school, there's only 3 grades, right? In the ABC family, but you don't want to get any C's in grad school.
Right.
Do most of the undergraduates start with critical practice in their first semester?
Yeah.
That's right.
Yep.
All right.
I decided to go through the Lawrence Tech's program just because, one, for simplicity, and two, for timeline.
Sure. It's a fast timeline.
Yeah. The faster I can get done with it, the quicker I can get focus on working, more or less.
Mm-hmm. And, you guys can start taking your exams right now. I'll just repeat that. You guys can start sitting for your AREs while you're in school. I mean, you may not be ready, but you may not pass, but that's okay, because you can always take it again if you have to. But the way the NCARB is structured now, you can take it while you're in school, and that's kind of the mode of what you're saying, Cody. It's the sooner you get done, the sooner you can start, engaging in the profession and ultimately become licensed, right? Because I think if Michigan has like 2,700 registered architects in the state practicing architecture right now, I think there's like 8 of them that are under 30. Right. So what that like, so I'm going to like do a visual, right? So what that means is the shape of that population is a pyramid, right? The ones that are 55 and older, like my age, they're the ones that have like the most density, right? So there are more architects my age and old, well, 55 and older, practicing in the state of Michigan. And I suspect Indiana and Texas is no different, for example, right? Or New Jersey or Connecticut. So it's a kind of a pyramid, right? And so, and a pyramid wants to sit like this, right? Like Cheops, right? But the pyramid of the profession is upside down. So, I mean, and if you've ever belonged to a synagogue or a church or Boy Scouts or Girl Scouts or any community service organization, you all talk about membership, right? How do you grow the membership, right? It happens in all sorts of things, right? They talk about it in golf. They talk about it in, they're talking about it now in terms of trades, right? Plumbers and electricians and carpenters and masons, that there's no tradesmen. And it's all 55-year-old old farts like me that are talking about like, what's going on? Why aren't there any young people going into our profession? And the answer is because there's no young people interested in going into the profession. So what NCARB has done, I think we've talked about this. They've created the IPAL program, and they've readjusted the rules for the AREs so that in concept, right, you could be moving along in the program as an undergraduate, working in offices and getting NCARB hours and sitting for your exams. And so within the time of graduation, in concept, you could be receiving not only a diploma, but your license. Or more likely, since we're not even finished with the first year of IPAL yet, more than likely within the first year of your graduation with the Master of Architecture. You still need the Master of Architecture from most schools, at least in Michigan you do. But like the average is like 7 years, 5 to 7 years for people that have just graduated with their masters to, pass all of the, to hit all the hours and to pass all the exams, right?
It's an interesting thing to talk. I'd like to compare the amount of hours needed to get into other professions to architecture, and one of them was how many hours you'd need to become a commercial airline pilot.
It's less.
Yeah.
Yeah, it's less. an accountant, it's less. Yeah, that's
I
that's
think a lot
something
of
that they
young
look
people
at.
are looking at.
How can this, how does this square? How does this reconcile? So they've been working hard to try to invigorate the profession by letting more younger people infiltrate the profession to sort of take that pyramid, right, and sort of start to flatten it out and to give it kind of a heel and then a shoe, right, to sort of stand on. Because if it stays sharp and pointy like that, it's going to tip over, right? It's going to implode.
With that said, have you looked at any of the ARE 5.0 stuff?
No, my team has been looking at that.
I have some colleagues who are on the committee that are they've been shipped out to do some of the testing materials.
Yeah,
and it's interesting because it focused more on the profession than it does the schooling
academic
of
instruction.
architecture. Yeah, so it'll. I haven't seen any of the tests yet. I don't know if they've actually started implementing the 5.0 yet.
Yeah, so I mean that's giving some credibility to the work study experience that IPAL is offering up, or it acknowledges the value of programs that offer the work study. Like up here, it's the University of Detroit Mercy, for example, and in Ohio, it's the University of Cincinnati. In Massachusetts, it's MIT. But not every school has a co-op program. But those that do generally produce students that are kind of, well, potentially more well-rounded, right? Because they've had some work experience.
Mm-hmm. So how about those Olympic closing ceremonies?
I didn't stay up that late.
Oh, it was fantastic.
Yeah, I bet it was. I enjoyed it. I actually enjoyed it this year. I tended not to watch Mike Tirico much. I like him, but he's actually from here. Or no, he married somebody from Ann Arbor. That's what it is. That's why he's always here. But I actually watched it on most of the time. I watched it on the sort of NBC Sports Channel, like where they just had it playing all the time. So I didn't have to I didn't watch him. Yeah, it was good stuff. Yeah, the end. So I didn't make it really much past the Olympics. Athletes walking into the stadium. I don't think I stayed up much past that. So it must have been like 9 o'clock, 9:30, and I think I retired that night. So that was. I don't know what they did after that, but the stuff that they did before they walked in, that was actually pretty beautiful. And how the ice or whatever they were walking on was, whatever that surface was, how that was telling its own sort of graphical story. Well, that was really quite stunning.
Yeah, they did a lot of that with the projection mapping, and
cool stuff.
They did a bunch of light stuff afterwards with shadows and everything. It was really cool.
And where are the Summer Olympics playing?
Is it Japan, Tokyo, I think?
Mm-hmm.
And then it's Beijing for the next Winter Olympics.
Cool. Well, Desmond, what would you like to do? I'm going to give you the authority to tell us what to do. Oh, you don't have a microphone? Oh, man. Pillow Talk was the name of a radio program that your company's boss used to listen to every night. The station was WNIC, and every night, so we would work all day long, and then Kevin Haas Yep, that's the station. Kevin Haas had all of these sort of side jobs. He was under contract for, he was under contract with Kmart, and he would do site plans, and he would do like 3 or 4 site plans a night, and he would work like 4 or 5 hours. And when he had too many, he'd let us work for him. And so, you know, you could make extra money working at night, just drawing site plans for Kevin. And he'd make us listen to this DJ whose name was Alan Allman, and his program was called Pillow Talk, and he was talking to all of these sort of love couples, right, that would be listening to these love ballads that he would play. A lot of saxophone, a lot of singing, and he was hysterical. He would make us listen to this stuff, and we'd all be going, this is so saccharine, right? It's this music is just too sweet, it's too tender, too emotional. Give me the Police, which was just starting to play in clubs like Bookies and things like that in Detroit. Give me at least some jazz or something else to listen to. And he'd listen to that music all the time. Oh my God. That's taking me way back.
Any band that played at CBGB's?
Yeah, so I imagine, I don't know that I saw any band that did that. I imagine that they, like Patti Smith did.
I think the Police did. The Police
Yeah, I'm sure they did. I never saw Patti Smith. I actually never saw the Police play in the 70s or 80s. But they played at Bookies. Bookies was sneaky good. There was just a dive bar on like 8 Mile in Detroit, and they got great bands to play there before they were even sort of known. The best one though is the Who, right? The Who was an English band, still around. Roger Daltrey, right, and Pete Townsend, Keith Moon, and Roger Entwistle, English band that you're going to crack up, but they were touring throughout the States back in like 1966 or 67, and they were like in Cleveland or Toledo, and some local young entrepreneur called them or mailed them or something like that, and persuaded them that they had this really big crowd in the Detroit area at this little known venue, and that they should come, and that they put up money to get them to come, and the Who showed up, and the Who showed up at Southfield High School. You can find all of this online. You can see the pictures of them performing. They took a bus up to Southfield, Michigan. They pulled in. They didn't know where they were, and they came in to perform. They played a 30-minute set. A lot of the stuff was from this was before the album Tommy came out, which was 1969. But I think you can probably look online and find a set list for it. So they might have played something from that. But I think they played everything else, My Generation, that kind of stuff from before that. But the band that warmed them up, the opening act, was a little known local band called the Amboy Dukes. And the Amboy Dukes' guitarist was, of course, Ted Nugent. And so that was the warm-up band for this legendary concert that no one seems to know, but you have to be really old like me to remember that.
Were you at that concert?
Mm-mm. In 67, I would have been 10.
Okay, I was guessing you would
Yeah.
have been a little young for that.
Yeah, I was 10, and that was 67 was kind of the summer of love, and so I was too young to participate in all of that.
So you're not much older than my parents, only a couple years.
Well, they would have been too young for that. And then, just 2 years later, right, was Woodstock, and I was probably too young for that as well. So good stuff, though. Yeah, the Who played here, and they were like wearing. They kind of like had costumes in suitcases or in luggage, and they took the costumes out and they had to like stitch them up because they were very animated. They were very physical and active on stage. If you've ever like watched the late Keith Moon play the drums, he was a madman, right? And Roger Daltrey wears next to nothing on stage, and the stuff was really sort of form fitting and body conscious. So he was always like having to stitch that stuff up. And then Pete Townsend is a real physical musician as well as a guitarist. So yeah, they were kind of like darning their own clothes, and would have been fun, right? Well, I know Dasman wants to keep talking. I think we'll just figure that Dan will let us know what he wants to do vis-a-vis your package that you submitted for today. We can look at that when you get back, but you may end up getting an apology with just a grade for the work that you did for his module for March 1st. I'll give you one more chance to ask any questions about the program brief. I think it's pretty self-explanatory. Otherwise, we'll end Pillow Talk now, and we'll let you all embark on spring break.
I got a quick question. Oh,
I'll let you go first.
okay. Nathan will go first then, I guess.
Okay.
I will. I'm coordinating with Jess. He's working on structure while I work on HVAC. We have two technical concepts for our structure above the podium. One is just a simple wood structure versus a more complicated CLT. Are we being encouraged to use a CLT system in order to work out some of the sustainability factors of that, or?
I'll let you ask that question to Dan. He'll probably want to answer it his way. I'm not encouraging one sort of system over the other. I know he produced a menu for you to work with. I think it would be interesting to look at your work in a CLT format, but I also don't want to discourage wood, because wood has its own challenges, right? Oh, looks like he's here. Wood has its own challenges in terms of like being able to carry masonry as a material, up 4 floors, 5 floors, and it has shrinkage issues. And CLT has sort of the concern of fire resistivity and the fact that it's sort of a novelty to building officials and building inspectors, that they may or may not be sort of comfortable with it. But maybe one of the ways that we move through this transformation is to look at it and study it more frequently, more often.
Sure. Great. Thank you.
Mm-hmm. Who was the other question?
That was me, Alec.
Go ahead, Alec.
I was just curious about in the previous critique, you brought up a project you worked on that used post-tension slabs.
Yep.
I think you said district lofts.
Yep.
I couldn't find exactly, because there are a bunch of different places named district lofts
in Birmingham.
In Birmingham.
No, there's two buildings in Birmingham that are called district lofts. One is the newest one, Alec, and it's all wood. Right? Okay. And that's the one on it's right on Eaton, and it's kind of shaped like a J, right? it's a bar that's been bent to conform to the intersection of a main street called Eaton and the cross street, which is, I think, Villa. The bar building behind it or east of it that's closer to the railroad tracks is the post-tension one.
Okay.
And they look identical. So from the exterior, you can't tell what the structure is whatsoever.
Okay.
And it looks like the building, by the way, you guys, the building that I showed you once this semester, the one that we're doing in Detroit on Jefferson, I showed you the slide deck. The owner has decided to go with post-tension concrete. And we're looking at an 8-inch slab. We expect no beams.
What is the span?
Well, we're still working out the spans on that, but they will probably be no more than 30 feet. So we're laying that grid out right now. We're sort of moving. There's a lot of things that are moving parts, but that's what they're looking to do. Hi, Daniel. How are you tonight?
Slipping and sliding on the way home.
I figured everybody's just like freaking out with all this March weather.
Sorry about that, but could not get here sooner.
No problem. So I don't know how you want to do this tonight. If you want to entertain the idea of presentations at 6:45, or if you want to go back to the sort of original sort of method that you've dealt with this before, the online format, and just review their work on your own and audit it and grade it, and then return the grades back to them when that's done. What's your pleasure?
It's up to you guys. At this point, I don't know that I have anything else to discuss at this point other than what you're going to present. So it's if you think it would be more constructive presenting it and asking questions about it or talking about it, we can do that.
We were just about ready to wrap up, and then I saw your icon pop in. Okay. I was just waving goodbye, and then I saw you come in. So
that's fine. If you don't think you can benefit from that, and you'd rather just submit it, and then I would submit review comments back to you with the markup sheet. We can do that as well. What are your preferences?
So there's a great voting system that could go on the chat box on the right.
That's fine with me. Which option are we talking about?
Yeah, Trevor, be more explicit.
Okay. Okay, so I've got Nathaniel presenting tonight. Possibly Jess and Nathaniel then, is that right? Jess, or is Jess with you?
No, Jess is away, so it'll just be me.
Okay, that's fine. Okay, so it sounds like you can go ahead, and then it looks like Alex might have some questions after that. Is that, as I'm seeing from here? I don't know about Stefan and John. What are your thoughts?
Sounds like the needles move. I'll wait till John and Stefan. So okay. I think the needles moved to closing the class, letting your written red pen comments prevail.
That's fine. I would say I will take on Nathaniel and Alex's. Nathaniel talking about his work, and then Alex after that.
Great. And I'm hanging around then.
And then anyone else who wants to after that point, you're welcome to do that.
Cool. So you're welcome to go then, everyone. And I'll say spring break, happy spring break, be safe. And don't forget, there's a benchmark coming up. Make sure that you spend time over the break working on it. So let's give, let's see, Nathaniel.
Sure.
You want the floor? I just gave you the floor.
All right. Let me pull up. All right, can you see my screen?
Yes,
yep.
You can see it.
Jess worked on the structural, so I'm going to kind of breeze through that since he has a better idea of that. But I did the bioclimatic stuff and then the HVAC and materials envelope.
Okay.
So we start with the building orientation. I did the math for the deviation of my site's 28 degrees versus the 18 degree of ideal. It's showing a deviation of 11.1%.
Okay. So generally speaking, from what I know about this with those I've worked with, well, I'm not sure I'm understanding your graphic necessarily, because it shows the ideal 18% counterclockwise off of east-west, correct? But your graphic shows something that looks like it's not 28 degrees off of east-west counterclockwise, but more like 45 degrees clockwise from east-west. What is there a graphic issue here?
I'm not sure. The site itself is naturally turned 45 degrees, so I was just adding the 28 degrees to that.
Well, I think you have to take this from in other words, these have to be apples to apples comparisons. Does that make sense?
Sure.
So
if I were to lay the building on the left on a north-oriented plan, my building should lay the same direction. So I've taken in the rotation of the site itself as 28 degrees.
I think you have to measure it from the east-west orientation that is similar to the example on the left. Does that make sense?
Okay.
Irrespective of the fact that the site is not on a cardinal coordinates. Does that make sense?
Right. So
that said, I would indicate, however, that is the site condition in your write-up.
Okay.
Because that, in a sense, drives some of the decisions. Does that make sense?
Yeah.
If you have a building that has to fit largely the footprint of the site that you have,
yeah,
which yours does, immediately there's constraints just by the virtue of the site itself.
Yeah, and that's a lot of the bioclimatic details that I'm finding, is that I'm meeting a lot of the issues or a lot of the criteria, and some of them I'm naturally not going to meet them just by the constraint site.
Okay.
Plan geometry is an example of that, where I had them reversed last time, where I'm 139 feet north-south and 156th Street east-west, or along the longer axis, but that's filling in the site. But again, the J shape is actually providing us a lot of southern exposure into the courtyard. So it's an attempt to reduce that cavernous feeling of the courtyard in our space.
Yeah, I would just say, for the topic of our discussion, show me an apples to apples comparison between the model reference on the left and yours that is that is measured on the same markers.
Okay.
And in your write-up, however, you can explain that the site is already shifted off east-west or cardinal coordinates by this amount. Does that make sense?
Yeah. So my deviation is going to be a lot more.
Probably, yeah.
Okay.
That's what I'm saying based on the graphic. It's
okay.
It would be okay.
So on my surface to volume ratio, I've been able to break apart each piece. I've reduced any of the areas that interact with the walls. Again, this is part of the benefit of the site and of my building shape. It's actually bringing that surface volume down, or surface area down. So I'm at 1.19%, while the ideal ratio is 2% or below. So my variance percentage is 40.5%.
Sorry, back up.
Yeah.
You're actually, if I understand it correctly, you're actually with a surface area to volume ratio. What is the numeric value? It's I don't think it's expressed in percentages, is it?
Based on that,
unitless, is it not?
I'm sorry.
I think they describe it as unitless, correct?
Okay, I'll double check that. I have that chart you sent me.
Right. Even though I know that surface area and volume obviously are not equal units, I think they express it as a unit. So you're there. So what I'm getting at is, they probably have for an L shape. I'm not sure if this is L shape. 2.0 is recommended. And you're at 1.19.
Yes.
So that may not be a negative because actually you have less surface area relative.
Well, it's a benefit from what I'm finding. The C shape is actually 2.0 as well.
Okay.
And that's the one I ran with. But it is showing that the lower the surface area, the better, because it's
Yeah, you could argue that from the standpoint of compactness, there's less surface area for thermal loss.
yeah. Great. So I've tried to orient you with our corridors. We do have, obviously it's contained within a double loaded corridor. There are a few pockets that have that southern exposure with the elevator core. That's an effort to mask it from the street view so that we can have more of our design in the front be the foreground. This also has the benefit of providing some natural ventilation from the west direction.
So I guess back up, I guess I would have in this graphic, probably the graphic you get from the book that shows you the graphic with the recommended location.
Okay.
For reference. And then just restate what they say. They recommend, probably corridors to the north, correct?
Sure. Yes.
And I don't remember where cores are, east or west or something. So then at least we know what that recommendation is relative to yours. I would say at this point, your explanation ought to be why you're deviating from that. Does that make sense?
Mm-hmm.
And I think the argument would be clear to me, at least, that centrally loaded corridor systems are the ones that are going to be the most efficient, right?
Yes.
Based on minimizing the floor plate, minimizing the height. Does that make sense?
Mm-hmm.
So I think it's a dictate of the building type and efficiency of the floor plate overall that necessitated that condition that you have.
Sure.
So that's what I'm getting at. I think, again, it's one of those, why we're not aligned with that, but we have a viable reason for so, and this is what it is. Does that make sense? That's the way I would pursue it.
Okay. Sunlight availability. It's just an effort to try and show the different percentages of sunlight. We're taking in consideration how the courtyard is affected, how the west face of our building during the summer months, how to help alleviate some of that late evening glare into the space.
And then again, I would sort of back up to that slide and just say, okay, what does the graphic that you get from the textbook say?
Okay.
The orientation should be.
Sure.
Okay.
Same with the site layout, the aspect. So this is where we started to get into more of the details of what some of those the PDF that you had forwarded to us about an age-based apartment and some of the amenities, trying to focus our features towards them, including window design, site layout, even calculating the daylight factor. It's all an effort to provide as much content towards catering to our clientele versus just a generic.
Okay, can you back up to the higher slide for a moment? Okay.
Mm-hmm. So we've started
the question I would have is based on the bioclimatic psychometric chart that we saw in the climate report by Dasman, right?
Mm.
They made a recommendation. I mean, there's a recommendation that certain strategies would be advisable for this climate, right? And that's recognized by the percentage of contribution they make to the comfort zone, correct?
Yes. Yes.
So what I'm getting at is when I look at this, well, first of all, I would probably have started my presentation on this with that bioclimatic psychometric chart, right? And then stating that we are going to apply the following, or we are going to respond in our design to these following conditions in the following manner, right? And so in this one, I'm not exactly sure I understand the site layout per se, but I think I understand the glazing condition.
Mm-hmm.
That seems to me you're talking about either a direct gain or blocking unwanted sun, right?
Yes. Yes.
Okay. So
and I do get into the bioclimate or the psychometric chart. So
that's fine. Go ahead.
So again, I tried to do the math. The document encouraged us to do the math just so that we understand kind of what we're trying to achieve, and then understand how.
Did we just lose you?
I think we lost the audio.
Yeah, he's had some problems tonight, so I think we have to wait for him to.
And we lost him entirely. Was there a problem with his internet connection, or?
He just sent me a note that he was having trouble logging on, and he's going to reboot, and he came in just a couple of seconds late.
Okay.
Alec, did you want to ask your questions now while we're waiting for
Let me
Nathan to come back on? Maybe activate your camera.
Yeah.
There we go.
Screen share this. So for the HVA system, we settled on option 2, doing the VRF system with the different pipes, high pressure pipes and low pressure pipes with the liquid refrigerant. And I noticed in your brief, it said the DOAS with ERV exterior location at grade and ground. But in the research that I produced, and in the research that you gave, a lot of the what they did was they would put the units on the roof. I'm curious, is that something that you're opposed to, or is that a fair placement?
I think it's fine if you wanted to put them on the roof. It's just a question of access to that.
Uh-huh.
Can you back up a minute, though, and show me that image that you had just a moment ago from the assignment?
Yeah.
Because I think there's something we need to move back up on the sheet.
Oh.
And a little further up, Stop there. Okay, so figure 4 on the right, what do you see there?
I'm sorry, I had some computer issues. Are you seeing my screen right now?
No, I'm sorry. We're just taking Alex's question.
Oh, okay. Sorry. Yeah.
That's all right. So on the right-hand side, you see figure 4 VRF unit in apartment, correct?
Yeah, it's an apartment unit.
Right. So that's basically those are individual units. They're similar to the Magic Pack, but they're just a VRF version of it. Does that make sense?
Yeah.
Okay. So can we go back to your plan again? The image you had of your plan.
Yeah.
So what I'm saying to you is that looks like a central system, right? And you're feeding it off the corridor, right? So,
right. And then.
All right. So do you see the difference between what I'm seeing on the 5th floor and what we just looked at in the axonometric a moment ago?
Right. But again, with the resources provided, they did it by floor, with a central unit, and then the mode selection box would distribute the pipes to the various units throughout that floor.
Right. I mean, I think that's obviously another variant form of it, but maybe it wasn't clear with when I submitted that the intention was, though, that it was supposed to be a sort of a package unit per apartment. Does that make sense?
That this wouldn't be an effective.
I think Professor Farlow would want to weigh in on this, because I know there tends to be a preference per package units, it seems, today.
They just drive a good value, right, for the developer. That's all we're seeing, quite honestly.
Okay.
I
think that, but let me back up a minute. I think there are some arguments for why you should have a full a building-wide system, and not just the individual sort of package units. And they're there, and I'm not saying you're wrong for doing this, but I think at this point, because of the nature of the discussions in the studio, I think it would be wiser to do the following. Basically, try to adapt that to be a unit-based system. Now, that does require there is an external unit. Did you see that was showing up there?
Right.
So that's either going to be attached to usually that's sort of attached to a balcony, right? Or it probably could be along an outside wall, right? Yeah. Where it's going to be enclosed on the outside wall.
It would be a smaller unit, because it's just the per unit.
Right, but it has to be accessible probably from the inside of the apartment, and it's got to have a vent screen on the outside.
Right.
Yeah, so it's going to have a louver on the outside.
That's
that
right.
is another component that you have to compose.
Right.
So on the balcony side of the project, it can be on the balcony, right?
Uh-huh.
That that would work there. But on the other side, on the inside, the courtyard side, then I think you're back to like a louver condition.
Right.
That said, what would it be that you would have to feed the floor? Well, I could see one of two approaches. First of all, on the floor itself, there's no reason why, if you have some small common areas, right, and some of you do,
right,
you could not just have a unit.
On other floors, I have a small one here and a small one here.
Right, you could just have a unit that feeds that small common area. Let's say it's a laundry or a small exercise room or a community room, right?
Mm-hmm.
Then the next question would be, okay, so what about the hallway, right? How does that get fed? From my perspectives, I would have thought that would have been through the central plant system.
Right.
That basically, you're moving air through the central plant system where the cooling tower is either on the lower, or the condenser is either on the upper level or the lower level. As you said, it could be in either place. And there's a common set of ducts that are bringing in fresh air into the system. Normally with buildings like this, and I'll let Professor Farlow weigh in, usually corridor buildings, whether they're office or residential, they want a positive air pressure in corridors.
They do.
The argument is, and I just didn't know if that applied with sprinklers because I haven't had that discussion, but the argument is that if a fire is going to start, it generally starts in the occupied space, but not the corridor, simply because of the nature of the activity and the amount of combustibles that are there. And so by positive pressuring the corridor, you always push smoke out of the corridor and back to a unit.
Right.
Does that make sense?
The other benefit of that is that if a lot of people are cooking curry, for example, it doesn't necessarily end up in the hallway, right? Or doing maybe, let's just say, illicit things in their room that involve rolling tobacco, funny tobacco, right? So that's one of the other dividends of pressurizing the hallway.
Yeah, I think there's an odor control. I think that would be important, but I think it's largely the life safety issue that.
Yep.
So.
Okay.
And if there's a control box for that unit that's basically deciding how much refrigerant is needed for heating or cooling, that's probably located on the floor because that's probably one zone.
Right, because I mean, in the different, like specifically, I'm referencing the Lennox video on YouTube that you shared.
Right.
It broke it down by floor. They had two or three exterior units that they ran the pipes to one of those the MS, the mode selection boxes, and then it spread out over the unit.
Okay.
Over that floor.
Right.
And I saw an advantage in that is where I wouldn't have to be putting one of those VRF units on every balcony.
And actually, that's when you read the articles about the advantage of that over the unit-based systems, that's actually one of the arguments, as well as they do say it's a reduced cost because there's fewer refrigerant pump systems that are needed to accomplish that. Now, the downside of this, I'll just give you an example. Some of you might have remembered in Southfield there was a large apartment complex that had to close, right? Recently, back in the winter, maybe about a month ago. I think it was because there was a problem with the central HVAC system plant and the boilers, right? So here's my point. If you have a central plant failure and you're in a critical time of the year, extremely hot or extremely cold, and in this case, because you have seniors who generally are more sensitive to temperature extremes, you're going to evacuate your building if you can't fix it quickly.
Gotcha.
And what happened to all those people that got evacuated in Southfield? Well, the developer, I guess, or the owner probably had to pay for their hotel bill, right?
Yeah.
For as long as they had to be there. So I would say Professor Farlow's point would be your owners don't want to see that.
Okay.
That's right.
Right. So when their apartment unit breaks down, maybe because all of the units around them are still conditioned, thermal loss, temperature variation is not critical. and they can fix that unit and get it back on. And they're only, if at worst, so to speak, they're evacuating that family or that occupants
Right.
only, and not the whole building. So I think you're almost looking at it from the standpoint of the worst case scenario in terms of systems going down.
Yes, a system failure.
Right.
What that would look like.
Right.
And then the ground floor would be serviced by one.
Correct.
Okay.
Right, and that's again part of what you would call the central plant version of this.
Right. So it'd be a combination. The residential floors would be all unit based, where the ground floor is going to be serviced.
Yeah, except again, you could feed the corridors and maybe a community space or a lobby from the central plant system. Does that make sense?
Yeah.
Yeah.
So you've got some in other words, you do have. I don't want to give you the impression that you don't have vertical risers in there. You do. You've got vertical risers for air, and you're going to have vertical risers for the piping, which is the refrigerant.
Right. Right. Of course.
So.
And those assemblies can get buried in the corridor walls. They can get buried in or around stairways and elevator cores by sort of fattening up some of those walls to allow, shaft assemblies to, integrate with them. That's one of those are the ways that we approach that.
Now, what's the geothermal for?
That was another suggestion noted by your information.
So let's back up to that. Could you use a geothermal in combination with a VRF? And the answer to that is yes. There are some examples of that. They do work. You have to go through a heat exchanger unit to do that. In other words, you have to extract the temperature from the geothermal or geoexchange system to augment the tempering that you have to do with the VRF. Okay. Now, as I said, there are some good examples of that in some projects. There are examples that are evidence that they are efficient. They're really good on the efficiency side. So let's talk about geothermal. And again, I think Professor Farlow needs to weigh in on this. What are the pros and cons, and can we do it, or shouldn't we do it, and why? So in terms of basically where would the geothermal heat pump loops be underground, right? I know Professor Farlow said that there was some evidence that, at least with some conversations he's had with their mechanical people, that, hey, you really don't even have enough space, beneath the building to run all the wells, right? Now, not being a part of that conversation, I don't know what the assumption was. If the assumption is it's a normal building, not tightly insulated and reducing the air infiltration, and has a high-performing HVAC, it may have had a higher load for space conditioning than a building like yours, which we hope will not have those issues, right? In other words, when that happens, the number of wells goes down, right? Now, the other system that you're seeing in front of you happens to be one that was used for an apartment complex in Chicago. It's the Rosa Parks Apartments. You see it there. And it's like a charging system that has water surrounding the well beneath the ground, and it is a vertical well.
Yeah.
So it does provide more efficiency as a result of that. Now, the downside of your case is I don't see any way you could put a system in that would be a horizontal loop anywhere.
Right.
You have to have vertical loops, and they have to be under the building.
Yeah. Right.
So what does that mean? There are 2 projects, maybe 3 that I'm aware of. I'm not sure about the third one. There's one in Toronto. I think it's a higher end luxury condominium that has the geothermal wells beneath the building, because there is no room on the site.
Right.
There is another project called the it's actually in the packet. It's one of the case studies in the packet. I'm trying to think of it. It's in Milwaukee. It's a HUD project. It's a homeless shelter. Sorry, I'm not coming to mind here, but I know it, but I can't spit it out at the moment. That project, it's in the packet of the studies of projects at the back of this assignment. That's a homeless shelter project. I'm not sure that it became affordable, maybe because they were able to get loans, or subsidies and grants to do that, because it's a nonprofit owner. That could have been the other reason why that was happening. So I think the problem on our site would be, you know, you're forced to go under the building,
Yeah.
right? There's going to be some cost premiums there. And then the other issue for me has always been, well, how do you ever access and maintain that?
Right.
And I'm not an expert in this, but my only possible explanation for why this would be viable is they probably have a series of pressure sensors in each of the wells so that they can tell if there's a leak. That means there's going to be a pressure drop.
Mhm.
And then secondly, they probably have a series of shut-off valves or diversion valves where if they have a well that's leaking, they basically have a bypass. They just shut it off and move the fluid around it. Does that make sense? Because you can't have the leak because obviously it dissipates the system. And secondly, you probably can never access that well. So you just have to bypass it. Does that make sense?
Yeah.
That and again, I'm speculating, but that would probably be the only way I could think of to be responsible to maintenance or defect issues in the future, how they can do something like that.
Mhm.
So I don't know, Professor Farlow, what do you think about the geothermal? Should we?
Well,
consider it,
I'm
or should
intrigued
we-
with it. You know, and my mechanical engineer is Strategic Energy Solutions. They're over in Berkeley on 11 Mile. Steve DeBaradine is a big advocate of it, and he's actually an expert on it. But he told me that in sites like this, and in sites like the one we're looking at on Jefferson, that there's a couple of things that we need to recognize, and it's putting his interests sort of behind the 8 ball. He's saying that we would need 300-foot bores at 20-foot centers for a geothermal network for a building this size. That second, all tax incentives have expired for geothermal. That happened in 2016. My notes are not comprehensive, though. I don't know if he means nationally or within the state of Michigan. That could be borne out. That you need 2 meters per unit in order to monitor this approach. And there was a time when this was like a 3.5 to 4 year return on investment, and that was in good times. Today, he's telling his owners that they should expect it to be 20 years. So those are terms that are a little bit more frustrating,
Right.
Mm-hmm.
and may cause people to be a little bit more hesitant or really run the numbers more carefully. But if there's like a building sitting on top of this geothermal field that inhibits its access and maintenance, that could be a deal breaker for any of these urban sites.
Right.
Now, I'm not saying all of this to be a buzzkill on it, but because I think in an environment like this, this is a workable thing. But I want you to know this when you're going into like practice, the culture of practice.
I'm hesitant going further into geothermal because I knew how that there are some it's expensive and there's some risks to it. That's why I wanted to ask about it tonight.
No, it's been a good discussion. I'm glad you brought it up. With the tax incentive going away, I can see that as a major inhibitor. That's unfortunate.
It's
and
fun.
I'm not sure I understand it, but the other side of the coin would be if you wanted to consider it on a site like this and you didn't want to use it for the entire building, but let's say you just wanted to augment the central plant portion of the building, right? Obviously, you'd have a much smaller field. Does that make sense?
Yeah.
Because most of those spaces are inboard, meaning they don't have exterior walls anyway, right, or glazing. And there's a very small percentage of the volume of the building. You might have been able to get away with a much smaller field area, right? But as I said, I don't think any of our projects actually have any open space at all, right? So I'm not sure it's even practical to consider it further at this point.
Right.
So.
Sorry, can I add something to this conversation?
Sure.
What about that space between the building and the historical house next door? In our plan, we had called out that space as a potential water discharge area or water recharge area for our, and a little park. What about a slinky system for that combined with the vertical pump.
So I mean, yeah,
sorry.
I guess that land. I mean, I think initially the conversation was to sort of suggest that would be an option if, right, you sort of portrayed it as something within the studio that was understood that it would need to be negotiated with that homeowner, that there would have to be some sort of transaction and easement developed that would be written into the property in perpetuity, or that there would be some sort of a lease agreement. And in my mind, that was initially meant to be understood by you all as maybe something like in the terms of like a soft touch, like a garden, right, or something like what you're talking about, but burying something beneath the land and crafting some sort of other alternative for like a geothermal field there. That would be a taller order, I think, and and for this studio that might be a bit presumptive.
Okay.
I mean, I agree with Professor Farlow. You're going to have some serious discussions regarding basically the ability to have something like an easement, because essentially what you're asking for is not just temporary.
It's permanent.
Right. They're going to expect to be able to have maintenance or servicing access to that. Obviously, as long as the building is there.
Okay.
So that's a big change. I think, you know, at this point, it sounds like Professor Farlow is saying that's perhaps outside of the bounds.
Maybe a little bit.
Oh.
I mean, but I think what your initial sort of assumption was, you guys, you know, Richard and Cody, was like fine, but I think anything more than that is probably a little presumptive.
Okay.
I mean, I agree with your strategy. That's exactly what I would be doing if I didn't have enough land on the site. I'd probably be thinking, okay, where can I get an easement? Who's around me, right? Like, maybe you'd have a better chance if this was a public park. I'm not sure.
Okay. Thank you.
Are you done, Alec?
All set, Alec?
Okay, to continue the conversation about the VRF system specifically, do you think I could make these the units, instead of being every single unit, the VRF system can control like a wing of the residences in another section? Because that was the really main advantage that I saw in the resources that you provided, is that the piping can go a pretty significant distance, and you can use individual controls on several different units through one system.
Well, I mean, again, I'll defer it back to Professor Farlow whether he thinks that, you know, there's a strong argument for viability of a central plant opposed to the units and individual unit package units, because I think that's what we're talking about now.
Right.
Yeah, I mean, I think in all of my experience, we've either done the VRF as like a heat pump, or sort of the sort of equivalent, which is the Magic Pack. We've seen that on higher end condo buildings. We've done the sort of the chiller on the roof. We've done the 3-pipe system, and in those instances in condos, Alec, there's like a homeowners association fee that you pay every month.
Yeah.
And you're pouring as a homeowner, you're pouring a lot of money into the upkeep and the maintenance of the building. So those things are getting regular checkups. They get pre-season, like cooling season checkups. They have generators that run on backup. They get post-season cleanup and maintenance. Or you know, the homeowners are generally funding the sort of durability program and the maintenance program of those things. In these apartment buildings, it's sort of like you're sort of getting a rental car, right?
Yeah.
You know what I mean?
Yeah.
It's and anybody can drive a rental car. And sometimes when you're driving a rental car, you're maybe going a little faster than you should. You know what I mean? It's so the apartment takes on a higher level of service. It takes a lot more beating up, and it probably doesn't get as much maintenance.
Right.
So I actually like the individual notion, like the VRF is within the unit or the Magic Pack.
Yeah.
Because it also confronts for you the challenge of integrating them into the architecture, into the unit design. So it's a good exercise in the context of the studio. But I think both work, right? They both the central plant and the individual unit are very workable. But I want you to understand why developers go one way over, say, another.
Yeah, that makes sense.
I think the ownership structure is important to understand. So I'm glad that came out, because let's put it this way. If the condominium association, or let's say it's a cooperative, right?
Yeah, that's another one.
Where basically monies are provided by you as the owner, and they are earmarked or targeted for a particular type of expenditure, right? So in other words, the owner, let's say, has to show evidence that he or she is using for those funds for that purpose. So as Professor Farlow said, let's say maintenance and upkeep of the main central plant. Now, if it's, as he alluded to, if you're a renter, how they use the rent money is at their discretion. Does that make sense?
Yeah.
They, if times are tight or things are difficult for them financially, they may pull back on maintenance, right? It's at their risk, but they may do so. So, I think I'm capturing the same comments.
Yeah, I agree.
Yeah.
Of it.
Okay. Are you all set, Alec?
You all set?
Yeah, I think so.
All right. Thank you, Alex. All right. We're going to go back to Nathaniel again.
All right. Sorry about that. I don't entirely know what happened.
Okay. No problem.
Let me go back to share screen. Okay, can you see my screen?
Yeah.
Yep. We're back.
I'll keep checking in every once in a while.
Now, you used, did you use one of the two links I gave you for the daylight factor?
Yes.
Okay, thank you. Did you cite it?
I tried to cite the housing lin.org UK, which
Okay,
had the
thank you.
formula there.
Thank you.
Did you hear anything about the sustainable landscape?
No.
No, we did not get to that point.
Okay. So one of the goals that we're trying to do is to utilize a lot of native plant life in East Michigan. We're taking in consideration what the psychometric chart had also stated, using some low-hanging trees that can create a windshield into our west portion of our courtyard, since that's open to the neighborhood. We're introducing some fruit-bearing shrubs that can be gardened, as well as rooftop gardens or terrace gardens, in order to kind of create a community within our building, but also allow the building to give back to the community so that it's working together. This also has a lot of benefits to our building when it comes to insulation, seeing as it helps manage up to 80% of the rain and regulate heat emissions. Again, the building is trying to help manage its location and its actual rain collection within the space.
So I'm sorry, can we back up to that for a minute? So there are a few things to think a little bit about. I know that there's the general recommendations for sheltering sites from wind, and that's fine. It does get to be a little difficult to understand exactly what's happening in an urban condition where there's a lot of existing buildings, right? The microclimate patterns of wind are perhaps not always understandable. Regarding the notion of like gardening conditions, I have seen in some public housing, like independent living senior complexes, where they actually devote a part of their landscape space to gardens that are tenant gardens. Residents can come and work the gardens if they want to, because that's their hobby and that's what they want to do. So that's kind of a neat idea. I guess I'm asking in your case, would that happen on the ground level, or do you see that happening on a rooftop like the diagram or the photo on the right? Where would that happen?
I see that happening on several of our terraces in order to manage some of the square footage that we're trying to keep from the
Right.
I'm sorry, the occupancy load. There we go. I see some kind of unkept portion of those terraces that will just be allowed to grow. They get managed within the season, but they're kind of left to grow and be appreciated. While other parts of our roof will actually be focused on the gardens, giving the patrons of the building that access. I do see having a first floor, seeing as we have kind of a village style courtyard where it's open on both ends, bringing the community into the space, creating a community garden, trying to use our building as kind of a hub for that community. That does solve some of our sustainable issues with water management, but it's also going to benefit our building with the regulation of rain and heat emissions.
So I guess the question would be, in part, I think this would probably be a management related issue as well, since they're going to have to, they're going to be overseeing how some of this would work. On the ground plane, the issue with that would be because a lot of that's publicly viewed, right?
Mm-hmm.
People would be concerned about how well maintained some of this would be. Would be people actually maintaining it the way they would like. The other problem with some things, sometimes with fruit, for example, is just the maintenance of them and the upkeep with them, and the making sure that they're not, fruit drop is not a problem, making sure insect conditions are not problematic. So there's a reason why we don't see a lot of permaculture, as it's called sometimes on communal properties. It's just it tends to be a maintenance issue. In terms of using it for the roof, I think you'd have to be careful about the loads you'd be adding to that.
Yeah, definitely.
I don't think it's going to be a low impact.
Right.
I think it's going to be a heavier impact sort of a green roof type system. And then I guess in the upper story condition, then I guess there's probably less visible public impact by those decisions, right?
Mm-hmm.
So if things go awry and they're not working out, well, we're not going to have that to be in the public eye, right? It's just we're up. So I think that's it's positive. In terms of rainwater, I mean, I guess the other side of it is again, if you collect it on a roof, of course it adds loads, but also if you use it for gardening, you can't use it for something else, right? So you use it to offset toilet flushing water demand. So kind of keep that in mind.
What does that mean? So offsetting from like gray water, is that what you're saying?
Yeah, I mean, usually, one of the applications of gray water is to use it for like toilet flushing application, because it doesn't need to be potable, right?
Sure. So shower water, anything we could collect and then use it so it'd just be non-potable water.
Yes and no, because at least rainwater, for the most part, we know doesn't have chemical additives.
Mm-hmm.
When you talk about collecting the shower water or the sink water, as you can imagine, the problem becomes, okay, what's in that?
Yeah,
Right.
I guess I took it after the fact. Where you're saying the rainwater is the first step, I'm thinking you can collect some of the gray water and then use that to water your plants.
Correct. And I'm saying that if you're talking about gray water coming out of the sink or bottom of the shower or the tub, the answer to that is I'm not exactly sure it's free of chemicals or elements that you would want in the garden. Maybe that can be the water you would immediately recycle into toilet flushing water, right?
Sure.
But maybe in this case, cistern or rainwater from the roof, or rain rather, would be diverted for, in your case, landscaping, because we know it's generally clean, right?
Sure. Great. So now I get into the bioclimatic chart. This lists off 10 or 5 of the top percentages. So I created my own psychometric chart. It focuses on comfort, internal heat gain, dehumidification, and heating and dehumidification if needed, and then passive solar gain also. And then I kind of focus on those 5 elements as key features of what our building is trying to help alleviate.
So, what does the 9.2% mean, and can you do anything for it? The number one. Can you explain that? Can you answer that question for me?
I did create the chart, and I'm still trying to understand it entirely. I'm assuming that is more towards creating comfort within the space and what a person would prefer when it comes to their inside controlled space.
So my understanding is that that's basically saying that 9.2% of the year, without any form of passive or active system assistance, you're in the comfort zone range.
Okay.
Does that make sense? And essentially, I mean, it's just indicating that, you know, obviously if we were in a much more temperate climate, right, that number is going to be higher, right?
Sure.
So what I'm saying is there's nothing we can do about that. As I understand it, that's just that's the nature of the climate condition and human comfort levels for temperature and humidity. So it's nice that it's 9.2%. You'd wish it was larger, but I'm not sure what we can do with it.
Okay.
So let's go on, because we need to make sure we understand these. Number 9, internal heat gain. Can you tell me what that is?
So that is the sunlight coming into that space. It's 20% of the sunlight coming in and heating up that space.
Okay. What internal gain? Let's just back up a minute. That's basically equipment, lighting, occupants that create heat.
Oh.
Okay.
Okay.
So that's also something that, well, we could actually impact that. Normally, it's accepted as a given, right? So the occupancy, that means you and I and visitors, you know, we give off heat because we're body temperature 98.6, right? Your laptop's producing heat right now. The light bulbs in your space are producing heat. When you're running your refrigerator, it's pushing out heat. When you're running your stove, it's creating heat. All those things, right? So in a sense, because this is a cool climate, this is classified by ASHRAE as cool and humid, internal heat gain might not really be a negative, right? Because you might benefit from having that heat. Does that make sense?
Yeah.
So again, the only way I could imagine you'd impact this would be you've made some selective decisions about mitigating internal heat gain. For example, you're in a hot, arid climate or hot, humid climate. You don't want the extra heat, right? So what could you do? Well, I'm going to find cool light bulbs. I'm going to find equipment that does not produce much heat. Does that make sense?
Yeah.
That's probably, so I'm not sure we can do too much about it here. And I'm not sure that based on the temperature condition being too cold for comfort most of the year, it's a negative. So we're lucky to have it is what I'm getting at. And just the nature of the occupancy. Does that make sense?
Yeah.
Let's go down to 10. I'm sorry I'm quizzing you, but
no, you're fine. Please do.
I don't mean to put you on the spot, but I just want to make sure we understand what they mean.
Well, I need to know. I want to learn. So.
All right, number 10. Can you tell me passive solar direct gain?
So I imagine the passive solar is actually the uncontrolled. The sunlight is coming into the space, and it's warming the space up.
Right. I can't tell you I know the distinction in terms of this software, what he means by low mass or high mass. But basically, of course, if you do want to have passive solar direct gain, you do want it to fall on some thick, dense material that can absorb solar radiation energy. So it's a concrete floor, right? It's a brick wall, something like that.
Okay.
And it's not impeded by anything, right? It falls directly on that. All right, dehumidification only?
That would be the non-humid portion of the space, I'm assuming.
Right. So maybe there's going to be like a desiccant wheel, possibly, that could be part of your energy recovery ventilation system, right? Part of your DOAS, your intake and exhaust.
Sure.
That could be, you know, a desiccant wheel would be a way to remove. That would be a way to remove some of that humidity. Now let's go to the last one. I'm sure you know what that is.
Yeah. So bringing that heat and humidity back up.
Right, and
makes
that's not passive.
Yes.
That's your HVAC system, right, in the power plant. So the implication for me of 16 for you would be to go back to what we have talked about in the past. I want the bioclimatic conditions to be favorable, right, because that is related to energy consumption. I want a high or well-insulated building. I want to hit that ASHRAE 189.1 standard or better it, correct?
Mm-hmm.
And I want to have a tight building with reduced air changes per hours, right?
Yes.
Air barriers and using air barriers, for example. Does that make sense?
Yep.
So as long as we're clear about that, then just make sure that what you're talking about is a solution to those major bioclimatic conditions sort of match that. Would that make sense?
Yep.
Okay, thank you. All right, so was there more? All right.
Yeah, I can breeze through some of this. So Jess was doing the structure.
Okay.
So I can't talk too much about it. We've got our dimensions. We are showing structural grids in the parking garage. I know there was a little confusion about that, but we have been showing the grid. We've got the dimensions so that you can start to understand how far we're reaching. First floor and the lower level are all concrete structural podium. And then
Can you back up for a minute?
Yep.
Sorry. Can you go back to the subgrade, the parking?
Okay.
Okay. So of the structural system options where you're choosing, which one? Do you remember which one you chose?
I know it's a concrete column. Again, Jess has been running with this one. I'm sorry he's not here tonight.
Okay. I'm not sure I understand column 7.5 and 6.5G.
So 6.5 and 7.5 are what is holding up our
Okay.
bracing above.
All right, can I go back down then? I'm sorry. Is there any way that, let's say that 6.5G could become
7?
Well, I'm thinking, yeah, could it be either 6.5F or could it be 7F? Can you go up a level?
Yeah.
Yeah, I mean, see, they're kind of, I mean, I like where they are as a composition, but if they could have more sort of coherence to the pre-existing grid, it might be more compelling and less like arbitrary.
Mm-hmm.
Well, I mean, they're not arbitrary. They were done for a reason.
Yeah.
Right? But what they're not doing is they're not coordinated with the overall system and the conditions beneath it because they're forcing you to add something.
They're right. They're not aligning with the original grid.
Right. Sure. And so if you can't maintain the intent by going at 7F and 8F, you understand what I'm suggesting?
Yeah.
Then 6.5G and 7.5, whatever the other one was.
It's not even on a vertical line.
They go away, right?
Yeah.
That would be my recommendation. Also, it's a little odd. I see a column line along F, right?
Yeah.
Level, but I don't see any columns on it. What am I missing? Oh, they're below?
Yeah.
Okay. So let's back up a minute. Go back to the subgrade.
What are they picking up above?
Column line F between bays 1 and 2. How does my stair work? Do I have a column going through my stair, or are we
or a beam?
Or a beam? Sorry, we don't have a beam going through the stair.
Not in the axonometric, but it is. There's actually more columns. Well, maybe,
I guess that's not the landing side of the stairs, is it?
Yeah, it is.
It's below the landing.
Well, based on that detail in the axonometric, it looks like there is some sort of a beam somewhere where my stair is going to be.
Yeah, penetrating it.
Does that make sense?
Yeah, you guys might need to resolve that.
I mean, either slide your stair over or slide the
column.
Okay.
That would, sliding it over would probably be an easier resolution.
Yeah, I mean, it looks like the space to the right, to the right of the stairs is a vacant void. Also, your floor to floor height there is not very large, right?
No, it's about 12 feet.
Okay. I mean, you have to do the math, but see if you could do it, within the 16-foot bay, right?
Mhm.
You know
Yeah.
what I'm getting
That'll
at?
be tight. That'll be tight to do that.
Yeah, I agree with you. It probably is. Or can we make the FG column line bigger and
Yeah.
make G small, GH
'Cause
small?
then it picks up the elevators, and then can we go back up one plan?
Go to the main floor. Is that what you're asking?
Yeah. Yeah, I don't. So I guess I don't think it has any problem. It might clear that
Yeah.
vestibule there between 2 and 3, but I don't know where those columns are on this level. And
Yeah, it looks like column line G should be to the right about 2 feet anyway.
Yeah, that's what I'm saying too.
And if that's the case, then
and so should F. Really, the way that you've delineated columns in the building, because I don't know what is it picking up above, right?
well,
There
there's
would be
there's a registration issue that's
yeah.
coming up.
So he just needs to keep refining that with you.
Yeah.
Okay.
You're real close.
Okay.
So there's F.1. So for some reason, F.1 wasn't showing on the other one, but
yeah.
I would say, let me just make a quick suggestion about showing a plan which is supposed to show structure. Maybe just put a gray line or a watermark for the building outline.
Yeah.
And just let structure be black.
Yeah. I like that idea.
And maybe, I don't know, blue column center lines or something, so that it really we know exactly
everything pops.
Yeah.
We can find it. I'm a little concerned about column 5 again for the same reasons Professor Farlow mentioned earlier. Is that supposed to be at the edge of the building wall, or?
Yeah, I think it's supposed to tighten up, and then these two don't exist. Or none of these.
Right. So
those are gone.
Right. There's some cleanup work that needs to be done.
Yeah.
Okay.
Okay. So, and this just starts to show you how those different structures stack on top of each other.
Yeah, the hard part about the drawing, though, is that because it's a nice drawing, and I appreciate the effort to do that. It's because there's so much spatial information there.
It's too complicated.
Sure.
I'm losing, for example, the location of structure in some of those levels. Like, other than the parking level, as I get to the upper 2 levels, I'm having a harder time tracking where structure is. Does that make sense?
Yeah, the walls almost need to have like a 25% value compared to structure, which
or put them in as a very dotted line.
Yeah.
Only for the outer walls, but not for anything on the inside.
Yeah, don't show them windows and mullions, for instance.
Right.
Okay.
Don't show stair risers and treads. It's too much information.
Right. Just show it as the box void.
Okay.
Right.
So here you start to see he's got arrows showing where the pressure.
Yeah.
Everything's happening. Well, I did have a question for you, Professor Faro, about you had suggested CLT when we were talking about wood structure.
Sure.
And one of our original concepts was we would have a concrete podium with just a simple wood structure where load-bearing walls would contain our 4 stories of living. Are you encouraging us to do CLT for the sustainability purposes, or are we still flexible on what the wood structure above looks like?
Well, to the answer to that, you're still flexible, but the rationale for CLT, from what I've been reading, largely has been the sustainability attribute. That is to say, it's a renewable resource.
Okay.
So, I think Professor Farlow is okay with CLT as long as you can justify the system configuration is within the basic rules that the system can provide and structure support, and it meets the building code requirement.
And that's exactly what we were talking about when you were coming in, Dan. That this is such so we're not in Portland and we're not in Istanbul, right? We're the different. There's a different sensibility about wood or building codes, for example, respectively. And I know that I think I read just the other day that in Philadelphia or somewhere in New Jersey, there's going to be a new 7 or 8 story group of buildings that's going to be all CLT. It was just an architectural record. It has yet to be like built, but they've got elaborate renderings and drawings. So I know that more and more building officials are warming up to it. I was saying that I think in the context of our studio, this is a perfect opportunity to test and evaluate and make the case for it. So if that's something you're keen on doing for your reasons and other reasons like hitting lead points, then I would greenlight it. However, and I think I was saying this just as you came in, however, you may fight the resistivity, the hesitancy, right, of a local building official who just can't wrap their minds around it.
Right.
And so
to go back to Professor Farlow's point, though, too, I think before you even go down the, I mean, this is I would say in a practice setting. I think Professor Farlow can correct me if I'm wrong. Before you even go down the road of experimenting with the CLT and a design method and a design investigation in the office, I would think your project manager is going to have a conversation with your code official and even find out if that's an option.
Yep.
Because you're not going to want to waste time with it if you know if you're turned down.
Right.
Can I ask, along the left-hand side rooftop, I see some sloping there.
Yeah, and that's us trying to play around with how the facade on the exterior works. Right now, it's showing that sloping. We probably would have a low slope, especially if we're going to have a rooftop garden up there. This wouldn't be necessarily an option.
Okay.
It was early in the concepting that we were trying to kind of create this contained shell, and we're still in the design phase of what that rooftop may look like.
All I'm saying is that at that kind of volume, attic volume you're talking about, you would have to have some structure there, right?
Yeah. Yes.
Also, just so you know, since that's unoccupiable space, that would have to be partitioned off in like 3,000 square foot areas.
Yeah.
In terms of the roof plan, and then fire stopped, right? And then ventilated.
And fully sprinkled.
And fully, yes, sir. Good.
I've done a few of those. I know.
Yep, you know exactly what I'm thinking then.
Okay. Okay. So again, we have a few of just the elevations from cutting off into the courtyard.
I'm sorry, can you back up? So what is the material between columns 2 and 3?
So that is actually our, I'm looking at our elevator shaft.
Yeah, well, I think I said this the other day that the elevator actually has an overrun.
Mm-hmm.
And if you have any roof amenity space on the 5th floor, that space needs to be accessible by virtue of the elevator. So that's going to change the silhouette of the building.
And when we were talking about occupancy and trying to manage all the terraces that we have, would introducing a stair over by column 1 where our other stair is, making that more of an occupiable space, and then having a second set of stairs, can you exit from a rooftop onto another terrace, go back into the building, and then enter the same stair as a fire exit? Or because your one fire exit is blocked off going down to the 5th floor, you're still cut off from that one stair?
Is that the height you're at, 58 feet? Is that considered to be an elevation by which the fire truck ladder can reach you and can remove you from the building? Because my question is, if that's the case, then you don't go back in the building.
Yeah.
Does that make sense?
Okay. Is that, and this is just out of my own curiosity, is that part of a code evaluation that we could say that?
So one of the reasons why the size of the rooftop amenity space was the way it was written in the program is that you would only need one means of egress from it.
Okay.
Does that make sense?
Yeah.
It would still need to be accessible, but its footprint and therefore its occupant load would be under the threshold of that triggers 2 means of egress.
Yeah.
So to go back to my original question, between 2 and 3, that looks like CMU block. Is that correct?
Doesn't it?
Yeah, it's the wall family that we use for structure for thickness right now.
Okay, so is that meant to be a core shear wall type element?
It's a core wall, and we will clad it in a complementary material.
Okay, but when I say if it's a core wall, then I mean, what is it built of? Is it built with grout or cement?
Yes, it'll be CMU
reinforced
block
with cement inside or grout inside?
Yes.
Built, of course. Okay, so it could actually carry load, could it not?
Yes.
Gravity load. Okay. So in the event that you're looking at CLT, I don't know how that works. Does the CLT then form a chase that this core sort of slides within the chase, right?
Yeah, I don't know.
You know what I'm getting at?
Yeah, and
Or
it
do,
should.
or do you connect the CLT back into the core and it's got a supporting condition, right, from a gravity standpoint?
The way our floor plan kind of works, the elevator is independent of that initial structure.
Okay.
So it could kind of hug up against it and not rely,
not touch on it.
I think that's fine because at that point you separate the trades, right?
Yeah.
And then also you can use it for a lateral load stiffener because you're right, hugging it is what it does if there's a lateral load, right? It comes in contact with it.
But at the same time, even though it's probably 12-inch CMU block, even though it's probably got reinforcing and grout in it, it's not going to be able to act as a contributing shear element if it's independent of the CLT frame, as I'm understanding you, Nathan.
It's not working against it, though, is it?
No, but I'm just saying it's not.
It wouldn't be reliant on it.
That's correct.
Okay.
No, it's not a gravity load, right?
Correct.
So it's only if the floor diaphragm shifts and it comes in contact with that that it could add stiffness. So that's
then it could, yeah.
Only a lateral element would be
right. That's what I was talking about.
Okay.
Yeah. And then this is just looking towards the southwest corner, showing the different levels of terraces. We've started looking at families for the railings and everything, as we discussed the other day.
Right, and I do think, again, if you look in the packet that I sent you about systems towards the back, there's various types of cladding, and some of them are products that could be used as railings. And I do think that the whole nature of the envelope has to come about from an understanding about, what the intentions are, so to speak, with this. And I'm glad we're just not, we're getting away from just sort of putting on the standard Revit file element. So.
Okay. So here you start to see some of the material show through on the surface. We do get into the materials at the end of the document, talking about using natural woods, fiber, cement, cladding, and then brick as kind of our majority pieces, and then concrete as our supporting structure.
Nathan,
what is that? Sorry.
When you look at this section more carefully, it looks like there's some sort of poche or lintel or header above the windows. When I look at the dresser, for example, right, I see some poche between the top of the window and where it picks up, in this case, the roof or any of the floors. But when I look at the section, when I look at the elevation to the left, that header is not apparent. Those windows are actually maybe shorter and more rectangular in proportion, or more square in proportion.
Also,
am I missing something there?
Also, the depth of the balcony is
shallower than
extremely shallow. I mean, I'm not sure that you could use that as a balcony at that depth, right?
I don't know that you could stand on it. It's sort of like a fat Romeo and Juliet balcony.
Right. So really one of our concepts was to use nano wall, which is just removing the door and then making your open living space as your balcony.
Yeah.
So it would work more as a Juliet wall.
But I think the wall section is not accurate.
There's something not quite right there.
You follow what I'm saying, Nathaniel?
Yeah, I'm trying to see if there's a column line I can reference to see. It may be a different section. So
yeah, that may be. But your elevation's cutting through the part that I'm liking, and then it's showing something different in section.
Yeah.
Right, and then there's these issues of, I know that it's like steel, I don't think would be showing up if we're going to CLT, and if it's concrete down below, I'm not sure what the steel sections are doing there.
Yeah.
Also, it looks like at the ground level. I'm sorry, could you scroll up a little bit on this? No,
Or
move the whole
back up.
drawing upward. Move the whole drawing upward on your slide. Yeah.
You may not be able to.
Or yeah,
You
can
want me
you
to zoom in?
shrink the size of it a little bit? Yeah, shrink it down. No, smaller. Thank you. Stop. Go larger.
By one. There we
Stop.
go.
Stop. There is some impression that maybe I'm not sure I understand this, but as we get to the edge of the balcony, right, in the section, right along there, that looks like there's a wall, an outer wall there, right? Then I see what looks like a concrete column that we cut through at ground level, but then below that at the parking, then I don't see the column unless it's behind something. I'm not sure I understand what happens at the parking level. Do you understand what I'm getting at?
Yeah.
Now, and that makes me wonder, because if that core wall, if that's what it is in front of the column at the ground floor, it would also be in front of the column at the subgrade level of parking. And if it's not, I would be seeing a column at the subgrade level of parking too. Does that make sense?
Mm-hmm.
Okay. So
Nathan, you just need to like pour over where this is cut in the building relative to the skin, and make sure that it's the most straightforward cut, so that it's not getting confusing, particularly below grade.
yeah, and I think at the rooftop level, we're going to have some more thickness for parapet, right?
Yes.
Okay. Are the windows meant? I'm sorry. Maybe it's just a rendering issue. It looks like the windows along column line 5 actually move back and forth.
Yeah, I'm not sure what's going on there. They just need to be aligned.
They are meant to be aligned. Okay, sorry.
Yeah, it's all part of the cleanup process we're going through right now.
Okay.
So this is an additional section. I'm not sure if it tells us any more.
Okay.
So then I go into the HVAC conservation. We're looking at the hydronic radiant floor cooling and heating system. They do create a dry panel system that sits on top of your structure. So it's independent of any kind of a wet grout or any kind of an inlay. It also makes it more flexible for when we need to repair it or change out the system. It does have its efficiencies. As we go through the presentation, I start to identify a lot of the benefits of the radiant control. Again, it with lower temperature water, it's able to produce the same amount of energy as heating a house with just a standard air handling unit. I show alternatives between the solar collection and a geothermal. I was listening to you talk about the impracticalities of geothermal in our site.
Yeah, I'm not sure geothermal is going to be on the table any longer.
Okay.
I just think with the tax incentives and the full footprint across the site, and questionable whether or not we can actually get a sort of like a easement agreement from a nearby property owner, I think all those things are weighing against it.
Mm-hmm.
Have you done this kind of heat strategy in a building, Nathan?
The Indianapolis Airport uses it to heat its Civic Plaza, which is the pre-security. We use that.
It's indoor.
It's indoor. It's such a large space that they used it to heat just the point where people are at, and then let it dissipate into the sky. So they didn't try to introduce a lot of HVAC above the structure. So it's really uninterrupted structure, and then it's just heating you from the ground up, which does have a lot of its benefits, especially for our age group.
So can you go back over? So on that drawing, I do see, the solar panels, right? And then it looks like it is combined with a green roof, right?
Yeah.
So one of the things I think you're going to have to think about is that, if you've got people up there and you want people gardening, I mean, if that's the intention, right?
Mm-hmm.
I think you're going to have to take a good look at how that can happen. I have seen some projects recently, some in California, other places, where they actually create sort of like a lifted canopy condition above the whole roof, and the solar panels are there. And so that if you're on the rooftop, you're kind of covered by the solar panel canopy.
Uh-huh.
And it keeps you out of the sun. I guess it keeps you out of the rain, right? And then you could, circulate underneath that, for
Sure.
whatever reason.
That's cool.
And
That is clever.
I have seen some of those, so that's a possibility. I'm sorry, of the options that we gave you for mechanical systems, which one are you?
The radiant heat flooring, so option 4.
Okay.
And that utilizes the compressor, the balcony.
I was going to say, I know one of these units actually does have a package unit for the floor, and it distributes the tempering or conditioning through a hydronic system. Is that the one we're talking about?
Yes.
I think so.
Okay. All right. Is this heating only?
No, it would be cooling as well.
Okay. So you know what some of the issues are with cooling, don't you?
The fact that we need to draw fresh air, create positive pressure.
If you have hydronic for heating and cooling, remember that sounds good, but it doesn't put any air in the building. So
Yes.
You're going to have something that brings air into the building, like the DOAS.
Yep.
Right. And probably some emitter that at least would temper air, right,
Mm-hmm.
as it comes in. So keep that in mind. Also, with the hydronic cooling, we know we've got to watch floor temperatures, and we have to watch humidity levels, right? Otherwise, we have dew points hitting the floor, and we have possibly water, right, forming on the slab on the floor.
Yeah.
Can you back up a minute? So one of the ways that going back one more.
Yep.
Can you go back? Okay, back again. Okay, so I noticed. Sorry, one more back. I apologize. I noticed that you're showing a wood system, right? Like engineered lumber.
Yeah.
Okay, I have seen those, right?
Yep.
And I think one of the advantages of that, as you mentioned, is going to be the accessibility, right? You can get to it. The other advantage is because the wood is not terribly conductive, we probably have the ability to avoid the notion of dew point and condensation forming on it compared to a slab, which is more conductive, right?
Yeah.
I think that's a positive in that respect. I have just one more thing, though. While I've seen that for heating, the engineered lumber on the heating side, I've not seen it on the cooling side.
Neither have I.
Have you found any examples? I know I sent you that material from Flack and Kurtz out of New York.
Mm-hmm.
Have they used it in a cooling condition, like maybe a gym, for example, for a school?
Would putting it in the walls or the ceiling, so it's a whole different system, would that?
I don't think you're going to make it effective if it's in the walls at this point. I think it's going to be confined to the floor at this point. I think that is a system that we know exists and we can find, right?
Mm-hmm.
There are radiant panel cooling systems for ceilings.
Okay.
So if the argument becomes, hey, I still want to have that, yes, you'd have to find a radiant panel cooling system that's going to work from the ceiling level. Because, let's just say we find out perhaps that the wood will not be able to handle the cooling side of that. I'm not sure, as I said, I'm not sure it doesn't exist. I haven't seen one that's a cooling. I haven't seen a cooling floor yet. I have seen the heating floors that way. Flack and Kurtz, that one reference I sent you, they're probably the experts. Maybe try to see if they've got some projects. I know they've done school buildings, and I may be wrong, but I think they did one with a gym floor.
Okay.
And that would have been the case where they would have done that.
So is the concern the actual material that the PEX is embedded in, or is it the material on top, the actual floor system?
For me, it's the material on top. As I said, I've seen it for heating. I just haven't seen it for cooling.
And one of the conditions that I was looking at is including a ceramic tile or a slate as our interior finish, trying to take advantage of solar gain in the winter on that material. That was one of the suggestions in the psychometric chart.
Sure.
And would that then alleviate the concern of the wood?
I think that most of the systems that I've seen basically are slab type systems for the cooling. I haven't seen done with wood. So yes, it would. And then you would have the ability to argue that it could be a direct gain mass surface, right?
Yeah.
Providing people don't have rugs over that.
Well, yeah, and that's part of, again, this is all trying to cater towards our age group. So removing carpets and the need for rugs by heating the floor directly. You warm from the ground up, which is what this diagram is trying to kind of display.
Right.
And
So
I think,
Yep,
rugs
go
on
on.
one hand could be the slip and fall incident that you don't want to have anyway.
Right.
Yeah. Yeah. So I go into Climax Solutions. I'm taking up a ton of time. I'm sorry.
That's okay. Everybody else can leave if they want. I'm not going anywhere.
Okay. So I try to explain the benefits of what it does for the human body, some of the climatic solutions, including what we're trying to do with bringing some of that space, or bringing some of the daylight into the space, heating up the materials, using lighter color interior finishes to brighten the space to increase the sunlight, and then trying to take advantage of vertical and horizontal louvers to bring light into as many of the zone or the units as possible.
Okay.
Then, so I started to construct a section. I have two versions of this section. One shows a CLT system. That said, I don't have any columns to tie it to. So I just showed the typical wood open joist system, and how, if you zoom in, you can start to see how that PEX system fits inside. We've got slate tile on top, and then insulation. And I'll do those calculations next just to figure out where our R value is right now.
But if we went to CLT, we'll see a much thicker subfloor, correct?
Yes.
And then
yeah,
probably a glue lamb for the main members, right?
Yeah. Yeah, it would be a much more comprehensive structure, which is kind of why I've been showing this one, just because of its simplicity. But that's not saying that that's our option. I just wanted to show something a little more detailed.
Okay. I just think it's got to, at some point the section's got to match up with what your structure is, right?
Right.
Yeah. And then we go into our exterior materials. So the rule of trying to hold everything to 3, what we're trying to do with our geode for the exterior of the building. So the John R. and Alfred will be our fiber cement cladding. What was formerly Oco, we're going to introduce more of a hardy plank or some kind of a modern cementitious material. It is recyclable, sustainable, and fire and insect resistant. So it's a really good material to work with. Plus it's an added insulation, a layer of insulation. We do have wood on the interior of the courtyard. Doing some research, there's a non-toxic modification called acetylation. Sorry. And that does make it resistant to fungus and bacteria. And since we're elevated above the ground, termite concerns is not, or insect concerns is not really a big worry of ours. And then brick, trying to complement the neighborhood, bringing that traditional material into our building just to tie it all together.
Is brick only on the lower level?
It's only on the first floor, yes.
So I haven't really seen necessarily the building code descriptions yet, but you would probably want to think about whether or not the exterior walls of this, based on the construction type, have to be made of non-combustible material, or if wood is present even in the siding materials, that it has to be fire retardant treated. Does that make sense?
Yeah.
Okay. I mean, a number of these products can be, but they have to be called out as such.
Okay. Great.
Obviously, fiber cement, I don't think there's an issue with that. That is, I think by its nature, isn't it non-combustible?
Yes. So we go into some of the other materials and envelope that we're looking at. So the glazing, we've been looking at a double pane high performance. Obviously, we could go up to a triple pane. How frivolous do we want to take this? Do we go all the way?
I've never done a triple glazed window.
Neither have I.
in my many, many years.
I don't know. I mean, my only comment would be if there was a thought about what needs to happen at the lowest level where you probably have quite a bit of glazing, right? Then again, my point would be you wouldn't be using very much of the material, but you would be using it in an area where you do have quite a bit of glazing as your exterior wall, and I guess it would be a cost issue at that point.
Right.
Can you afford that? I have seen some other products being developed. One of my, I think it's being referred to as vacuum glass. And I came across this last semester, but I don't know how commonly available it is or its cost, but they're talking about R values like 12, I think, with it.
Wow.
And it's completely transparent.
Wow. Okay. We go into the parking garage. Our materials is obviously concrete. Trying to introduce some alternative to raw materials like fly ash and blast furnace slag. And then our interiors, we're trying to take advantage of the tile and slate, light colored to increase our internal reflectance, and then taking advantage of any kind of architectural details like vertical and horizontal louvers.
Okay.
Oh, wrong way. And finally, so what I tried to do was quantify our elevations with the different glazing. Some of them were a little high on, and I think as we adjust our windows, those will correct themselves.
So what would be the aggregate percent glazed on this if you add up all these percentages together? Do you know?
If it like one big average?
Yeah, because essentially that's what ASHRAE would call out. But I know that it's smart that you did it based on orientation because it tells us something.
Right.
But I think ASHRAE would just say it's I don't know if it's 35 or 40% offhand, but
I think it was 35, but I can double check that.
It looks like you're not going to have a problem with that.
Okay.
Because I mean, I only see one at 37.
Yeah, that's the.
Everything else is below that or at 35. So my guess is you're fine.
Okay, great.
Makes sense.
And then I start to quantify how I might go about using R values versus U values. R value, obviously, I'm looking at my exterior wall section, while U values, I'm looking at the glass and trying to bring that down.
Right. And I think at this point, I believe it was Andrew's report, the ASHRAE 189.1, where he starts setting up the values for insulation requirements and glazing requirements based on this climate, right?
Okay.
My point would be you probably want to find Andrew's report on the 189.1, all the thermal resistance values, solar heat gain reflection, right?
Okay.
Go back to that and bring that forward and say, yep, all right, we know what those are, and this is what we've selected. Does that make sense?
Yeah, great. And just some cited sources at the end there.
Okay.
That's everything.
Very good. So the only things I would say, just a few comments you got from me already, but also probably saying, you need to tell us the building code issues, right?
Yeah.
What is my construction type? What was my height and area maximum? I've got sprinklering. What am I going to have for fire ratings associated with the corridors? What's my fire rating for the exterior walls, right? That makes sense?
Yeah.
So I would say kind of go back over that probably. That would be some things that we want to update.
Okay. Great.
I think for me, the radiant heat flooring is a lovely sort of thing. We've done it before, Nathan. When I worked at my previous office, the office that Dan knows, we did it in our most premium homes. So we would do radiant heat flooring that would sit on the plywood subfloor, and then we would add a network of 2x4s on the flat that would protect the PEX, and it would allow the plumber to sort of arrange and configure that radiant piping in the gap between two 2x4s on the flat. And then we'd put plywood over that. And then we'd put the wood floor or the tile or the carpeting, right? We never did carpeting in rooms. We always did wood floors with rugs. But it was a pretty thick deli sandwich of a floor sitting on usually pre-engineered wood trusses in these very, very sort of premium homes. So I've never seen it in an environment where it's been in a for rent kind of typology. And I've always seen, which is not a problem, I'm just letting you know that. But I've always seen it used in concert with a forced air system of some sort.
Sure.
Again, to provide the relief in August and July, July, August, and September in terms vis-a-vis air conditioning, but also like now, or in February or January, when we get like a deep plunge in the temperature, and since the radiant flooring strategy just takes a little bit longer because it's like a gradual heat. It's literally called a gravity heat. Since it just takes a little bit longer to bring that ambient temperature up, it usually needs in these climates, it usually needs the forced air to kick in just to temper the air and to give the gravity heat a little bit of an edge. Now that gravity heat won't run long. It'll just, it'll thermostatically kick off at some point, and then the radiant heat is working throughout the day, throughout the evening. But when we have these really bitter cold snaps, that's usually when it kicks in.
So to get back to Mr. Farlow's point, couple of items. I think that since that is a package unit, that means there's something out on the terrace, right?
Yes.
Right. So I think what you could do is begin to think about having a conventional emitter, right? Not the floor heating condition, but a conventional emitter that's also going to bring in your air from the outside, right? Maybe that emitter is going to be along some of the exterior walls where we're likely to have more thermal loss, right? So that's to provide the conditioning for the balance conditioning for the thermal loss that's going to occur on the outer walls, and that's your fresh air. Does that make sense?
Yeah.
But I think that fresh air, my argument is I think that fresh air would have to be there all the time, because if you're going to pursue a very tight envelope, right, very few air changes per hour, you're going to have to bring oxygen in.
Yeah. And from what I understand, the radiant heat only works when the space is, the radiant cooling only works when the space is airtight. So that may be even
it's coming from the dehumidification side of the problem.
Yeah, probably.
That's why you want the tightness.
Yeah.
The other point that Professor Farlow made about how thick will the floor sandwich be, I'm not sure, but I think on the other side of the coin, you could say, look, if the underside of the heavy wood floor deck that you're going to see in the CLT and the glue, let's just say it's a glue lam, lam beam, if that's appearance grade quality, and we do not have, let's say, significant ducts, and other than sprinkler heads, there's really not much in the ceiling, right? The point is, maybe it's an exposed ceiling. We're back to what Professor Farlow alluded to, sort of the loft appearance.
Yeah, sophisticated frugality. You accept, right, the presence of that infrastructure as something noble and something like desirable, and that becomes kind of the brand, right, of your development.
And that might help offset the notion of the thicker floor plate, because you're not we're not going to put a drop ceiling in it, for example.
Sure, you're not restricted with your interstitial space anymore.
Yep, that's correct.
I mean, it makes sense to do that maybe in some spaces where you want better, let's say, humidity control. Like maybe you'll drop it in the kitchen, maybe you're going to drop it in the bathroom, right? I'm not sure. Maybe in the main open spaces it's just open, and that's part of the character of the this of the space. You know, that it has that taller ceiling in, let's say, the living or dining area or bedroom, for that matter.
Great.
Okay. Any other comments or questions?
Oh, this is really helpful.
Go have a nice spring break.
Okay. Enjoy your spring break. Remember to send me this as an email attachment. You will be getting an email from me. I'm going to ask you guys some follow-up questions, so please keep an eye on your email before you disappear for spring break.
All right.
And have a good spring break. I think you guys are in good shape, and I didn't expect to see wall sections at this level, but I'm impressed with that.
Yeah, that's good.
Great. Thank you.
Thanks, Dan. Have a great break, and Nathan, you too. Okay.
Oh, I will.
All right. Thank you. Have a good week.
See you all
Thank
soon. Bye bye.
Well.
Take care.
Bye bye.